Greetings, this is Greg. This is my Fiat 1.4 Multiair turbo engine. We're going to give a quick tour of it, so if you're working on one of these, you'll know where the components are, and I'll just mention things that make this engine pretty special. I'm very happy it's together, and I'm anxious to get it installed into my 124. So we've got the timing belt covers in place here, and also this heavy aluminum block. This covers up the tensioner, the timing belt tensioner, and also has to do with the motor mount if this is installed in a front driver. So all that stuff would have to come off to do the timing belt, and I'll tack something on to the end of this video to show you how to do a timing belt change. Down here is the crank pulley / dampener that drives the alternator and AC compressor. This is a stock one. I considered putting on a lightweight one or an underdrive one. I know Brian and Engine sells one, and it certainly looks good. I just didn't get to it. I got too many other things going on, and this pulley's in perfect shape. So I'm keeping the stock dampener for now. I just want to be clear I'm not opposed to the underdrive or lightweight ones. They certainly are proven in this application. Coming around here, we have the intake manifold here, and there's a tremendous amount going on. So let's talk about this briefly. First of all, up here we have the air oil separator. It takes crankcase ventilation from here and here. Well, technically that's out of the Multiair / cam cover, but that area is vented to the crankcase, and thus crankcase pressure gets vented into here. And the purpose of this is to separate the air and the oil and allow the oil to drain back via this tube here. This is a huge pain in the butt to get on if the engine's in the car. Just trust me on that. The oil that does not drain to there takes one of two paths. If the engine is not on boost, the oil will get sucked in to the intake manifold here. The reason this isn't connected is because this is where I tee in for a boost gauge if I'm running a boost gauge that requires literal boost pressure. We often use types, the Vatrix one specifically, that just plugs into the factory boost sensor with a splitter. It's much easier to hook up. But back to the air oil separator. And then if you're not under vacuum, meaning the engine's on boost, then the air oil vapors come out of here and go into the intake system. And quite a bit goes out of there, which is one of the reasons I recommend a secondary air oil separator system on these cars. If you're doing a lot of performance driving and have a modded car, stock car doesn't really matter, but modded car, certainly with a lot of high RPM, high boost driving, you want to have a secondary one to reduce the amount of oil that gets into there. My intake manifold is totally stock. This is the throttle here, and it's electronically controlled just like every throttle in every modern car. This is the manifold pressure sensor, or what we call a boost sensor. It's not screwed in right now, it's just loose. It's actually a bad sensor. It's there plugging the hole because the sensor off this motor is on the engine that's in the car at the moment. And over here, this structure is responsible for venting fuel vapors from the tank back into the engine. It's a complicated thing. Fiat is really proud of it. They've got a patent on this whole system. And the way it works is this. Fuel vapors form in the tank, and they have to go have somewhere to go. And they go into a charcoal canister, and from there, they come up to this structure. Now, the structure has to get rid of them one of two ways. One of the ways is it goes back into the intake manifold via this hose here, but that obviously only works if the engine's under vacuum. When it's on boost, that's just not going to be a viable path. The boost would go the other way. So, when it's on boost, it purges it into a line that is connected to another line coming from an intercooler pipe, and it uses boost pressure from the intercooler pipe to create a suction effect and purge those vapors back into the intake system. It works really well, and it has very few moving parts. I got to say, it's a reasonably clever system, but it causes a lot of extra black spaghetti under the hood, which makes things difficult to find. in general, I'm not a big fan of this whole side of the motor because everything over here is hard to work on, and it's hard to tell what line's what because they're all black. Up here we have, these are the multi-air connectors, we'll get to that in a minute, and the fuel injector connectors are down there. You may not be able to see them. Anyhow, moving around this side of the engine, these are coolant pipes here, and they go to the thermostat, which is on the back of the engine when it's in a rear-wheel drive application. And this is not fun to get to in the 124. You definitely want to get this stuff on the car before you put the engine in. And also, these pipes have to go on before the intake manifold if you're doing it in the car. You will not be able to get those pipes on and off with this thing, with the intake manifold in place. And you don't want to have to take that intake manifold off. So I have this engine mostly together. There's a few things that aren't on it yet because they're things that I want to do once it's on the car. So that takes care of most of this side of the motor. I'll mention that the knock sensor is down here. You want to make sure that bolt is tight or the sensor won't work. So knock sensor there, throttle here, boost sensor, and air oil separator with a jillion connections to it, and the evap system with a jillion connections to it. So let's go around to the other side of the motor. There's a lot more action there. I'm going to roll my chair over there. Helps me hold the camera more steady if I roll the chair. You know what? Let me get that light. Okay, better, huh? All right, this is the Boost Solenoid. Very important. It takes boost from here, out of the compressor area of the turbo, routes it through here, and then the ECU, get the light over here, the engine computer then pulses this thing. There we go, you can see it better. It pulses that to let boost pressure go to here, which is the Wastegate Actuator. So when it's on boost, the amount of pressure going to that Wastegate Actuator, thus the amount of wastegate movement, is regulated by that Boost Solenoid. You cannot change it out to another Boost Solenoid to try and get more power. That's not a viable thing. Although you can get maybe a stronger, more reliable Boost Solenoid, but there's no performance to be gained there. Just be aware of that. Then this Wastegate Actuator, this is a source of a lot of problems. Now, in the old days, you could just adjust that actuator rod. You can see there's a nut and threaded section there. In the old days, and I'm talking about the 1980s, you could adjust that actuator rod to get more turbo boost. But today, it's all controlled by the computer via that Boost Solenoid. And what the car needs now is to see the amount of boost it expects from a certain amount of pulsing of the solenoid. In other words, it knows it sends certain signals to the solenoid that should equate to more or less a certain amount of boost as a result of this rod moving a certain amount. So you cannot adjust the rod to increase performance, but what you can do is sometimes the rods are a little bit misadjusted. You can adjust it and make sure it's going to optimize what the ECU is telling you to do. And the way I like to do that is I hook up a bicycle pump, just a little air pump, to this nipple, tee it into a pressure gauge, and it takes very little movement of that hand pump because you're not pressurizing a big area here. A little bit of movement on the bicycle pump, and see when this rod starts to move. I adjust it generally so, well, first of all, before you see it starts to move, make sure that it closes all the way. This little flapper should be able to go all the way forward. If it doesn't, you need to tighten the rod up. But assuming that that closes all the way, I'm going to adjust that rod so that it starts to open on the 2012, 2013 cars about 6 psi, and on the 2014s and up about 8 psi. Some of the cars, some applications with tuned cars and stuff may set it closer to 10, but that's the range. No tighter than that, or you will absolutely never get the car to run quite right. This turbo is highly modified. It's done by G-Pop. It's got 52 millimeter as opposed to 46 millimeter compressor. with extended tips to 55.4 millimeter. It's about as big a turbo as I could. It's about as, well, let me phrase it this way. It's the stock turbo, but with bigger stuff in it. And the parts that are in it, the turbine wheel and compressor housing, are about as big as we could reasonably do without causing some problems related to the shaft size, and also we could bias the turbo with different blade designs for higher RPM and higher boost levels. But this thing had to be streetable. So anyhow, I'm sure I'm going to be very happy with this turbo. I've run the same internal components before. The only change now is this thing has been, I'm not even sure if you'll be able to see it, but it's been really, really heavily ported, both on the exhaust side and the intake side, as compared to what I was running before. In addition to that, this exhaust manifold has been very heavily ported and matched to the turbocharger inlet by G-Pop. And you can see I've got the factory heat shielding down there, factory heat shield here. There's another heat shield that wraps around the turbo, but I'm not putting that on until the engine's in the car. So I think that explains what's going on with the turbo there. That bracket there that I have writing on, so I wouldn't forget to put it on, that is an engine hoist point. That's an interesting thing. There are three ways to get this engine in the car. One is with the hood off, you can hoist it up and drop it in. I've heard that it's possible to do that with the hood on, but I would not want to try it. You can also put the engine in from the bottom, which I'm not going to do. The dilemma I'm facing here is I'm not sure how I'm going to get this engine in the car, because I have to work by myself because of the whole coronavirus thing going on. So I'm in quarantine. So I think what I'll do is have my kids remove the hood. I can't really do that by myself. And then I'll use the engine to hoist it in. But anyhow, there's three ways. You can hoist it in. You can put it in from the bottom, which I don't think is a good idea, especially if you're working by yourself. And the other way, and it's way too late for this, is you can assemble this thing in the car. A normal human being can lift up the short block, meaning crank, piston rods, and block, and oil pan. So you can put the whole bottom end together, bolt that into the car, and then build the rest of the engine onto it. That's a perfectly decent way to do it. It's just not what I did. Also, this whole engine together, I haven't weighed it, but I'm a big guy and I'm pretty strong, but I'm not like a power lifter or anything. And I can actually lift this engine up off the ground. I can't lift it up very high, but I can lift the whole engine up. So, I imagine with 4 people, you could heave this thing up and in there if you wanted to, but that'd be very risky. If somebody pinches their finger, you're going to drop the thing, and somebody get hurt, whatever. But it is possible. This is much easier on the Fiat 500. It's ironic, you look at the 124, it's got this super long hood and tons of room under there, and you look at the 500. Well, the 500, although at first glance it doesn't appear so, it's actually generally easier to work on. It has access panels for everything. That big front bumper cover with the Abarth emblem comes off, and then all the structure comes off, and you can pull the engine right out through the front of the car. You can literally just put a jack under it and bring it out the front. It's much, much easier to work on this. This particular car is an E85 car. I'm not a huge, I'm not against E85. I guess that's another subject. I just prefer water injection because I can have pretty much the same power as E85 without the hassle, and I like to take my cars on trips. So, all right, let's continue moving around. We covered the turbo pretty well. Oh, here's the blow-off valve. I use the forged blow-off valve. There are other ones that are just fine. In fact, they're really all just fine. Any of them that are made for this car, they're fine. I just like the forged one. I like the external one because I like the whoosh sound. I will mention there are sometimes you do not want to use an external blow-off valve. One, obviously, if you're in an area where the local law enforcement is really against any kind of noises, you may want to avoid that. But also, and I've never heard of this happening, but in theory it could happen. If instead of water injection, I sprayed, let's say, straight methanol, which is a flammable mixture, and then when if I let off and shift gears, that valve is going to open, that bypass valve or blow-off valve, and a little bit of methanol mist is going to spray out of those holes. Well, that would be highly flammable. It's not something I want to start spraying around in the engine bay. So if you were running pure methanol injection, don't get this. Forge makes one that is not vented to the atmosphere. That's what I would go with. But I just run water injection, and I like the sound, so that's what I'm going with. Also, Wastegate Actuator. I've got to talk about that just for a moment. Notice that I'm running the stock Wastegate Actuator. Yeah, there's a reason for that. Now, the Forge Wastegate Actuator is also quite good, but no other wastegate actuator I have tested really works properly. The problem is, even if you get it adjusted to where the rod starts to move with the correct amount of boost, they all move an incorrect amount. In other words, it might start to move at 6 psi with a certain aftermarket one, but at 8 psi it's moved farther than the stock actuator at 8 psi, or moved less, or the movement may not be linear due to types of springs, either cylindrical or conical or whatever. The Forge one works just fine. However, the problem with the Forge Wastegate Actuator is that I don't know what spring to tell you to use, because they have changed the tension of given colors of their springs over the years. So Forge Wastegate Actuator, yes, it works, but you've got to get it and try it to make sure you can get it to emulate the stock one. So anyhow, this thing has a stock Wastegate Actuator, forged, Forge, that's the brand, like an iron forge, blow-off valve, and the turbo is heavily reworked by G-Pop, and I'm very happy with the turbo. And the exhaust manifold's also heavily reworked, and all that stuff is ceramic coated. The turbo is ceramic coated, the exhaust manifold is ceramic coated. All that was done by G-Pop also. I think it looks great, and ceramic coating does provide some level of it acts as a thermal barrier to some degree, let's say that. There's a lot of debate about just how effective it is, and I really don't know. Don't have a way, well, I guess I do have a way to measure that, but I haven't done it. There are certain companies like Jet Hot, and there's another one I think it's called White Lightning, where they apparently use a thicker coating. It's supposed to be better. Yeah, it probably is. I don't know. In any case, this is ceramic coated, and I'm going to be pretty happy with that. So let's move around to here. This is kind of interesting. Okay, this section here, that aluminum metal, that is the oil pump. And it, a downside to this the upside to this oil pump is it's perfectly reliable and it's great. But the downside to it is that I cannot prime this engine by, I don't know if you worked on old American V8s, but the trick is you'd put a drill in there and spin the oil pump a bunch to pre-lubricate everything in the engine. Not an option here. There's no way to spin that oil pump because it spins directly. It's driven by the end of the crankshaft. So in order to spin it, you have to have the crankshaft in, and then that'd be spinning over the whole motor. So there's nothing to gain there. What I'll do is crank the motor over without the ignition hooked up and without the fuel injectors firing. So we'll get oil circulating that way. Speaking of oil and the oil pump, get my light again here. Okay, this is the oil filter housing. You probably already knew that. The filter housing is well above the pump. The pump, of course, is way above the pickup. So in order to prime the oil pump, not necessarily after an oil change, okay, although maybe, but certainly in this situation, the oil pan is bone dry, the motor is fresh, it's all brand new. So in order to prime the oil pump, I have to do that by filling this with oil first. Actually, let me rephrase that. You fill the oil pan first, then you put the last quart or so in through this, and that primes the oil pump. If you don't do that, you won't get oil pressure. Of course, if you don't get oil pressure, the motor won't start, so there's not a lot of risk of damage, but just do what I'm telling you. Prime the oil pump. This is the oil cooler. You know, I remember like in the 1980s, this was Formula One technology, and now it's on pretty much every car. It is a fantastically good oil cooler, and it works by exchanging the heat from the oil into the engine coolant. So it is a coolant to oil heat exchanger, which is why this section of the motor is pretty busy with all kinds of coolant lines and oil lines and whatnot. Of course, the turbo has oil in, and on the bottom of it, oil out, and then this fitting on the side and its twin on the other side are for coolant in and out. Bit of trivia, this has to be more or less directly above the drain in any turbo car, at least any turbo with a Garrett turbocharger. It's allowed to be 15 degrees from vertical, but not any more than that. And if it is more than that, what will happen is the car will smoke like it's got a James Bond smoke screen on it. The Garrett turbo has to have gravity like that in order to prevent oil from getting into the turbine section. All right, coming down here, we've this coolant pipe. Actually, this is kind of an interesting thing. It seals into the water pump. I'll show you where that is in a minute. It's behind the timing cover, but there's another engine I can show you. And this coolant pipe seals into the water pump just with a rubber O-ring and pressure. And this, set the light down, this bolt and nut here is what is keeping, and you can't see it, it's way at the front, but that's what's keeping that seal working. So if you forget to put that on or something, or that breaks off or whatever, you can end up with just a heck of a coolant leak, and it would be hard to figure out because it would be up here somewhere, but the actual cause would be back here. So maybe something to think about. Now let's go around to the back of the engine, and I just realized something really bad. I'm going to have to bolt the flywheel to this, of course. That's not a problem. The flywheel's in the car right now. When I pull the other engine out, I'll put the flywheel on here. But what I just realized that's bad is, those are those bolts that may be one-time use, and it might be hard to get them right now, so I got to think about how I'm going to handle that. I guess what I'm going to do is I'll review the manual, and if they can be inspected, and you determine they're okay and reuse them, then I'll do that, and if they're okay, I'll reuse them. Otherwise, this might set my project back a week or so. Anyway, well, c'est la vie, as they say in France. All right, back to the matter at hand. This is the crank position sensor. Now, it picks up this ring. This ring is fitting over the back of the flywheel, and the ring is constructed in such a way that it tells the sensor where the engine is in its rotation. Now that sensor wire is a critical wire, and you don't want to have to change this, okay, once this engine's in the car. Now, of course, I've never heard of one going bad in a Fiat, but who knows. So this sensor provides a signal through this wire, and this wire has various little clips. There's one here at that critical nut we talked about, and on the back of the motor there's a little bracket, which I'll show you in a second. So make sure that this thing is all clipped in place, because you don't want anything bad happening to that wire. Actually, I don't have the bracket within arm's reach, but let me just explain where it connects to. It connects to here, here, and down here. This bolt down here is almost impossible to get to with the engine in the car. Not this bolt. Okay, this is the vacuum pump. We'll get to that. But below this bolt down here is a bolt hole. So what I suggest you do is, when the engine's out of the car, or anytime you take that bracket off, and you have to take that bracket off if you do a timing belt change, camshaft change, pull the cylinder head, anything like that. Cut off the little ear that goes down here. Actually, you know what? Let me just find this thing. I see one. This will save you an insane amount of work for being such a trivial thing. So this bracket goes like that, more or less. See that hole goes there, this goes there. Now I have cut off this section here, so I've retained the clips, which are important for this wire, and it's got some other fittings at the other end for retaining other wires. But now it's super easy to take off, because this bolt and this bolt are easy. I know this seems like a stupid thing, but just trust me. Just cut that off and and avoid that last bolt. You absolutely don't need it, and I'm not kidding when I say this will probably save you an hour every time you have to do a timing belt change or something. So we talked about multi-air a few minutes ago. The reason the engine has a vacuum pump is because one of the things multi-air does is it throttles the engine by closing up the intake valves. Thus, it can leave the actual throttle open more than it otherwise would be. And there's almost no vacuum in the intake manifold, for example, during highway driving. It saves fuel, saves emissions. So you still want your power brakes to work, so there's a vacuum pump. So that's a critical part. And of course that has to come off in order to do a timing belt change, because when this is off, it gives you access to the back of the camshaft. The vacuum pump is driven by the camshaft, and once this is off, there's a tool that goes in there to ensure that the vacuum pump is in, or correction, that the camshaft's in the proper position for the timing belt change. Like I say, I'll tack a timing belt change video onto the end of this video, so you'll be able to see that. Down here, this is the, let me get a light on there. Just bear with me for a second here. Okay, this is the cam position sensor. That's important, all right? This is for the thermostat and temperature, so that's totally different. Similar area, though. And sometimes you got to unplug this by feel. For example, any piggyback unit that's worth its salt connects to that cam position sensor to detect engine rotation. There's some on the market that say they do it through the OBD2 port. That's a bunch of nonsense. The OBD2 port does not give out information on this car anywhere near fast enough to change parameters based on engine RPM. What those units are doing is just changing boost pressure via boost. If you really want to mess with the boost curve, you via a piggyback, okay, not a flash tune. Okay, my phone camera cut me off there, but we're back in business. So, sorry about the interruption. So again, cam position sensor location, and that's where most of your better piggybacks connect. You can get very reliable RPM information from that, which you need if you're going to really tune this engine properly via a piggyback, because you have to be able to make different changes to the boost curve at different points in the RPM range. Now, there are some piggybacks on the market that don't connect to any RPM information, and they work fine, but they're very limited in their performance potential because you can only raise the whole boost curve. In other words, you can't raise it 4 pounds at 5,500 RPM, but only 2 pounds at 3,000 or whatever. You can only raise it 3 pounds throughout the curve, or whatever you're doing. Far less desirable. And I think we've gone around the whole motor. We've covered all of the key components. You should more or less know your way around one of these engines now. And I'll mention that these 500 A-bars, this particular one is Brandon's car. He's one of our tuners here. And he really likes E85, so as I mentioned, I think he's running his car on E85. But this is one of the lowest priced legitimate performance cars you can buy, and you can get a second-hand 500 A-bar for very little money, and it's really a fun car to drive and a fun car to tune. No, it's not going to beat a Corvette at the drag strip, or probably not on any real racetrack either, but it is competitive with almost anything on motorsports events that approximate real roads. For example, we've had some sponsored race cars do very well in hill climbs. We had, they also compete pretty well in rallies. Fiat entered a very early 500 A-bar in the Targa, Newfoundland, and took second place overall, ahead of a lot of much more powerful cars. And of course, that takes place on real roads, and a lot of it took place during bad weather, which heavily favored the Fiat. Also, we've had one car win the Red Line Time Attack Challenge, a sponsored car. So, while people don't think of them as really serious performance cars, they actually are pretty darn good, especially for the money. And most importantly, I think they're just a huge amount of fun to drive. I mean, just to fire this car up and just go zipping around, not driving crazy, but say driving at 7/10, it's really a fun and enjoyable car. So that's all for now. Next time I make a video, hopefully the engine will be in the car. I don't know when that's going to be. My real life work schedule is probably going to interfere with this. You know, I'm like you guys. I have the same problems you guys do. Real life interferes with my hobbies. So anyhow, I hope everybody's having a good day. Thanks a bunch for watching, and goodbye. And if you're interested in the timing belt change, just stay tuned. I have that from another video, which I took a few days ago, and I'll just tack that on to the end of this one. Bye-bye. Greetings, this is Greg. Let's go over the timing belt system on the Fiat 1.4. It's a good time to do it as I'm putting the engine together. There are no markings on the camshaft, sprockets, pulleys, anything. And that's per the factory manual and also my own observation. So the only way you can line up the camshaft and time it correctly with the pistons is with the proper tools. First tool, and there's several of them, is this piece here. This bolts to the crank gear here, and it only goes on one way. It looks like it wouldn't, but there's a little hole and a tab. This only goes on one way, and this locks the crankshaft into a neutral position. By neutral, I mean all of the pistons are exactly halfway up. That ensures that you can rotate the camshaft to your heart's content, even on a big valve, big cam motor, if you had such a thing. I don't. But you can rotate the cam all day long, and no risk of the valves hitting the pistons in this with the crankshaft locked into this spot. Moving along, this is the water pump. It's only held on by 3 bolts and 1 nut. Pretty easy to change. So, considering that you have to remove the timing belt to get to the water pump, and considering that the timing belt lasts 153,000 miles, so you don't need to change this belt very often. So when you do it, probably a good idea to change out the water pump and, of course, the tensioner at the same time. So the next thing is we got to get the camshaft in the proper orientation before we lock everything down. And the way that is done is you remove the vacuum pump, which of course isn't here right now, but normally there'd be a vacuum pump here. And then you put on this plate. This plate locks the camshaft into the correct position. Now, I want to be careful with that word locks. I guess it'd be better to say it locates the camshaft into the proper position. And you'll understand why I'm making that differentiation in a minute. It's very important. So once this is all in here, what you do is you use this special tool. By the way, this tool, there are a number of companies make these tools. They all seem to be the same. I've checked both beta tools and some no-namer I got from eBay on a factory engine that had never been apart, and they both lined up on that engine perfectly. So I haven't found any tools that are incorrect. I think you're pretty safe, but where they do vary is in this. And interestingly, I like this tool better than the more expensive one that came with the beta kit. This is the no-namer. Anyhow, it's just a little wrench. It fits into these 2 little holes, which seem to be different from the spacing of the little holes in every other belt. And as you move the tensioner, it will line the pulley up. See how it moves the pulley a little bit when I move the tensioner? Oh, I maybe didn't mention this. There's no keyway on this. This pulley stays correctly oriented to the camshaft entirely via bolt tension. That makes this bolt really, really important. So the way the cam gets put into exactly the right spot is literally, or where the way the pulley gets put in the right spot is via the tensioner. You tension the tensioner until there's a little tab and window there that line up. Not sure if you can see it right there. That's how it's supposed to look. Now, the act of tightening this nut tends to mess with it a little bit, so sometimes it's a little hard to get this perfect. You might want to go just a hair more, because tightening the nut loosens it. But as long as you're, let's say, here to here, you're going to be okay. So once the tensioner is tightened, you torque down this nut, and this is a scary thing to me. This nut, that one little tiny nut, holds this whole engine together. If that thing loosens up, tensioner comes back, belt comes off, disaster. I've actually never heard of that happening. This is one of those things where I look at it and go, how do, you know, I don't understand how that works, but it does. I use a little bit of blue thread locker on there just to be safe, but the manual doesn't even say to do that. So once the belt is tensioned, now what you're going to have to do is tighten this. And I'll put in the description the torque value. I think it's 88 foot-pounds, but don't go by the audio. Check the description, because that's that'll be. I'll be able to double check it before I write it in there. Now the problem is, if you just tighten this, once the right now our belt's not tensioned, but assuming it was. If you just go ahead and tighten this to the torque spec, you're going to be trying to rotate the cam, and with a tremendous amount of force. So much force that you will probably either break the tool that's bolted on in the back, or more likely break the camshaft at the back where it fits into the tool / vacuum pump. It's also possible you would break this structure, although I don't think that's going to break off. I think that you're going to break the cam first. Let's not find out. So the way we avoid that is with this tool, yet another tool. It's from Beta, and I don't know if I can do this one-handed or not, but yeah, there we go. So this tool fits into here so that you can put your big wrench on that bolt and provide opposing force with this, so that you're not putting all of the stress onto the cam carrier assembly or the tool itself. So that's it. You get everything lined up, you tension it, torque this down, and you're good to go. Let's move on a little bit. We'll go around the motor a little bit. This is the oil pump, and not too much unusual about it. I will mention, well, actually, I guess there are two things I need to mention about the oil pump in regards to overhauling these motors. There is a little tiny rubber ring with a tab on it that goes between the oil pickup and the pump. And that's not non-standard. It's just that on this engine, it's really easy to lose because of the way it comes apart. But this is the pickup, and the rubber O-ring goes into here. And it has a tab on it because it sticks out at that end a little bit. So that's very important. And another thing that's really important here is that because the pump is way above the oil pan, it has to be primed. And I can't show you how to do that right now, but I can tell you how to do it, and in a later video I'll show it. The oil filter housing would be, more or less in this area here. And what you do is you unscrew that, take the filter out, and then you fill that with oil. Well, first of all, you have to have oil in the engine first, otherwise you're accomplishing nothing. So you fill the oil pan with its oil, and then you fill the oil filter housing, and that will then fill via gravity, and it will prime the pump. It'll fill everything from the filter housing to the pickup, and you're good to go. So that's very important. If you don't do that, the engine won't fire up, and the reason it won't fire up is because the multi-air system won't work. So let's take a look at the multi-air system. Actually, you know what? Let's come back to the multi-air system. Let's just go around real quick. Okay, this is the knock sensor. That's got to be pretty darn tight, or it won't work properly. Don't remember the torque spec, but be aware of that. At the back of the motor, there's not too much going on. Crank position sensors located here in 2014 and later models only. There is a way to convert the older cars to the newer cars, but generally don't need to worry too much about that. The 2012, 2013 cars, the crank position sensor is on the front. I like that better, although I can't say I've ever seen one fail, so I'm not too worried about that. And, well, I guess that's about all I have on here at the moment. There's not too much else. So back to the multi-air. Multi-air, and there's a million videos on this, and some are really good and some are really, really bad. It's a pretty interesting system. I consider it superior to Honda's VTEC because it does more with fewer moving parts, and those fewer moving parts don't ever wear out. So here's how it works. You have one camshaft, and the exhaust valves are operated conventionally via hydraulic lifters. Okay, this is not a solid lifter motor. So they're self-adjusting hydraulic lifters, just like in a 68, well, not just like, but somewhat similar to, say, a 60s American car, other than the cam is acting directly on it. Also, they're flat tappets, which I'm sure you've already figured out. So there's nothing exotic here in the exhaust side. Now, the intake side, these lobes do not directly act on the intake valves. What these lobes do is push on this little roller follower, and this one is a roller, and it moves a plunger, and what that does is generate a tremendous amount of oil pressure. Now, it's using, this is not oil pressure that supports the motor. In other words, it's got nothing to do with bearings or anything, or spraying the pistons or anything else. It uses oil pressure to move the intake valves. Now, it's using common oil with the engine, so that's important to understand. It doesn't have its own oil supply or anything, and that's part of the reason that it's so important to use specific oil in multi-air engines and to change it somewhat regularly, because if you don't, it can affect the multi-air operation and or shorten the life and ruin this multi-air brick, which is an expensive thing. It's the most expensive part on the motor. It's $1,000, can't really repair it. You got to just remove and replace it. However, they almost never go bad. We'll maybe come back to that. So anyhow, this moves this plunger. That generates oil pressure using engine oil, and that oil pressure, in this case, is used exclusively to move the valves. This one moves the 2 valves for cylinder 1, and so on and so forth. The way it works is the oil pressure then goes through an electronically controlled solenoid that's over here. This is the electrical hookup, and these are delicate, by the way. You don't want to put any force on those. The solenoid opens up to let oil either actuate the valve or not actuate the valve. It can control not only lift and duration, it can actually open the valve once per intake stroke or twice per intake stroke. So it has tremendous capability. I don't know of any other valve control system on engines in production today. And there probably is one. I don't know every engine out there, but I don't know of any others that can allow the intake valves to open twice in one intake stroke. That's kind of an interesting thing. And this works extremely well. The only cases I know of where these fail is in Europe. It happened quite a bit in the early days because people didn't take the oil recommendations seriously. And if you modify this system in any way, you're really playing with fire. Interestingly, what will likely happen if you modify the system is the intake valves will hit the pistons. And I can absolutely prove that that'll happen. As a matter of fact, the engine that I've been running in this car as a backup had exactly that happen to it, which is why I got such a smoking deal on it from the junkyard, because the owner modified the multi-air system in such a way that was extremely inadvisable, and he was one of the people that did not get lucky, and 2 of the intake valves hit the pistons, and he swapped out the motor, and I got a great deal on it, fixed it, and I ran it for some time in that car. But now I'm getting ready to put my engine back in, which I'm very excited about. So that's about it for the multi-air system. If you just change oil in it and leave it alone, it's going to work great. And I'll mention that multi-air was the, how should I put this? This was the upgraded engine in Europe. In other words, if you bought a car in Europe, if you got an Alfa Romeo, you got multi-air. If you got a Fiat, you did not get multi-air. And when they brought these engines to the U.S., in order to make them more competitive in the U.S. market, they made multi-air standard. So that's really nice. It works extremely well, provides more fuel economy, more emissions. They actually biased it towards emissions. It potentially could offer a lot more performance. Unfortunately, Fiat set this up where the range of travel for the intake valves is not that great. In other words, multi-air biases it towards the not opening the valve side of things rather than the opening of valves side of things in this particular engine. And that was a little bit disappointing because they could have done a lot more with this than they did. It does have very low emissions, very good fuel economy though, and certainly provides good power. I just feel like it could have been so much more. But this was the upgraded engine. The non-multi-air was the downgrade. And that continues today. If you get say an Alfa Romeo Giulia like this, you get Alfa Romeo's 2-liter multi-air engine. If you get a Jeep, it's not the Renegade. The Renegade actually has this engine optionally. The Wrangler, the bigger Jeep. If you get a Jeep Wrangler with a 2-liter engine, you get the same engine but without multi-air. It uses double overhead cam instead. And there's some good reasons for that. The Alfa is a passenger car. They wanted to use the advantages of multi-air for the Alfa, but the Jeep is more likely to be operating in dusty remote regions where it can't have its oil changed as often. And so I think it makes perfect sense that they put the twin cam variant of the engine in the Jeep. But again, we're talking about the 2-liter engine, which is a newer design. It's actually much better than this one, although this is very good. So anyway, that's about it. Yeah, Multiair, it's I really like it. It works very well. You know, it has, like any engine, it has some limitations, but I think that this particular engine I'm building is going to work really well. And within those, it's going to rev to 7,000 RPM and make plenty of power. I have really no doubts. Anyhow, that's it for this episode. Hope everybody's having a good day and staying safe with the virus going around. Bye-bye.